Alright, we're on the air. Okay. Good afternoon, good morning actually, or whatever time it is in a place. My name is Bernardus, and today we'll be diving deep into the object oriented programming in Java, specifically the four pillars of object oriented. Before we begin, I'm gonna apologize in advance because I should upload the video today, but I'm running low on mobile data, so probably I'll upload this tomorrow, or if not, maybe on Thursday. I don't know when will. I don't really have that much mobile data to upload a video to YouTube. Alright, if it is small, probably soon. But if the video turns out to be big, I'm sorry, I'm gonna have to delay. So as you can see, this is my GitHub issues that I open. GitHub issue that I open. You can see my journey here. So yeah, without further ado, let's get started. So, the four pillars of object-oriented programming and the memory truth. Actually, I said that I would be talking about memory management, but turns out it'll be better if we delay this into next week, because next week we'll be talking about memory cost. But this week we'll just be talking about the memory truth and the truth behind object-oriented programming. Apologize again in advance if I say anything that's wrong, or you may correct me in the comment section, because this is public learning. I'm not intending to teach anyone. This is just me recording myself and explaining what I have learned throughout the week. So without further ado, let's get started. Object-oriented programming. It is a paradigm. So before we get deeper into the pillars, we need to learn what object-oriented programming is. Object-oriented programming, as its name suggests, is a software development paradigm, or a way to structure or encapsulate data and methods, which is just a way to modify data into a single class. So data and methods to modify data are bundled together inside a class, which allows for robust and structured software development. Object-oriented programming mainly exists in backend development frameworks, as they need a structured way to manage their data. Front, I'm not gonna talk about front end because I don't really know. Object-oriented programming has four pillars: encapsulation, abstraction, inheritance, and polymorphism. So the first one is encapsulation. Encapsulation, in short terms, is just principle of combining data and methods into one capsule object. This principle is the main proponent of object-oriented programming paradigm, which doesn't really surprise me since Java is an object-oriented programming language. Okay, it has basically three modes of hiding data. So encapsulation basically mainly talks about data and how it encapsulates it into one class and how you can hide your data. The first one is public. With unrestricted access, you can modify it directly from anywhere. So let's what? Okay. So public static void string main args. I don't know if I'm gonna. I'm quite lazy to be honest. Let's just copy paste this animal class right here, alright? Alright. You have private, you have protected, string is always big because later I'll explain why. Hobby, and then public string nickname. This dot hobby. I think, therefore I am. Yes. After hobby we have nickname. Oh, before you ask why didn't I use IntelliJ IDE, is because I need a way to code my C program. So since we are not doing anything big yet, I decided to just use Visual Studio Code for today. Alright. Now, let's put that into practice. So let's say I have an animal. Oh wait. So let's say I have animal equals new animal. Let's say I give him the name Max. His age is 1. His hobby is biting other people. And then his nickname is Max. So for private variable, let me explain the rest of it. It's similar to public. The only difference is that you can only access div if you're on the same package of subclass or are subclasses of this class, even in a different package. Private, simple, not allowed to edit or access except from its own class. I have this code. Why? Okay. Yeah. Okay, so let me explain what did I just do here. Oh. Okay, let's just ignore that for now, alright? So within this public class OOP, which is the starting point of our program with the public static void string main args, we create a new object counter. Counter is a class instantiated into an object with these 3 variables. We have first value, second value, and third value. So first value is private, second value is protected, and third value is public. So let's get back here. We can directly modify third and second value. The first one is valid because a public variable accessible anywhere. The second one is protected variable. It's valid because it's only limited to the same package, and counter.java plus oop.java are in the same package. This is invalid. You can directly modify a private variable. This is why we need getters and setters. You cannot modify protected outside the same package and private variables directly. Getters and setters are like API you call to make the backend to do CRUD operations in the database. That's basically it. And then we have the second pillar. It's abstraction. That's jokes aside. Abstraction means it's a blueprint for other classes, telling them what they need to do without telling them how. So let's get this into oop.java. No. I'm just gonna delete this one. This code is safe, right? Yep, I've put it there, so no need to worry about that. So I'm just gonna remove this oop.java because they have the same class and it's making up quite a bit of this right now. We just do java main.java. Okay, so let me explain it first. This is an abstract class, as you can see with the keyword, abstract keyword right here. It can create abstract method with no implementation, but it can also create a concrete method with implementation. When you extend the class, you must implement make sound with the keyword override. So when you do this, the dog can have the sleep method from the abstract class, but it must be forced to override the make sound abstract method. So sorry, I don't know why in VS Code it's like this, but let's just comply. All right, it works. That's basically it. Wait. Oh, also, yeah. We can do this. Yes, we can create a new dog with the animal type because we cannot instantiate animal directly, but can use an object of a concrete subclass. This will output bark, this will output the animal is sleeping. This is also valid because dog is dog, but dog is also animal, something like that. Dog is an implementation of animal. Dog has the method, define, abstract, but no implementation. In Java, you have what's called the virtual table. So what's happening is we instantiate an object with dog class, but with only animal methods. And when I call the method, it follows the pointer reference to the heap. Access the class pointer to check its metadata and find out it's actually a dog. Then it looks up the virtual table in the method area to find the implementation of maxSum. Just remember, cat is an animal, and dog is an animal, and also cow is an animal. So basically, inside each class, remember the what's called VTable, and then I call to the heap a virtual table. This is that's right, Mora. I forgot to put text everywhere. But basically, what this means is that remember that in the header, where's the header? Text header. Yes, we have mark word. This is deeply related to the related to the garbage collector. But we also have. I'm sorry. But we also have the mark word. The mark word is deeply related to. We also have the class word. This is basically a pointer to the object metadata, the class definition in the method area. And inside that method area, we also have the method definition. Implementation, may I correct? Something like that. I don't know, man. So next, we have polymorphism. So why bother with abstraction? Simple, to help with polymorphism. Polymorphism in the short term is just many class that has the same method but different implementation. So for example, a cat meows, a dog barks, and a cow moves. So with this example right here, let's copy paste it and then I'll explain it later. So we have a class, abstract class called animal. It has no implementation for make sound, but it has an implementation for sleep. Dog extends it, and then we have the bark, and then cat meow, and the cow moo. Everyone is the implementation. Everyone has their own types, but they can be grouped into animal arrays because they are animal. And we can loop through the animal arrays, and since the animal has the defined method called make sound, they can call it. So let's, for example, for the first call is call my. This will basically do my dog dot make sound, make sound. And when you call a function, when you call a method on an object, the JVM will go to the class word, follows the pointer to the object metadata, and then in the object metadata lives what's called the virtual table. Inside the virtual table lives the address on where the method implementation code actually lives, either bytecode or native machine code, which will be explained later. Then start executing the code where start executing the methods one by one. So let's save this one first, and then I'm sorry. Different IDE, right? Different IDE. Yes, bark meow mew. So, but there are two kinds of polymorphism. The first one is compile time polymorphism. As its name suggests, this happens during the compilation, mainly achieved through method overloading, where methods with the same name have different parameters. So, we don't need to run this one as I've put it. We have a calculator class with the same object called calculate, but they take different inputs. One takes 3 integer, one takes only 2, one takes 3 float. So when you run this one, calculate the compile time will, during compile time, the compiler who turns .java into .class will pick the correct method to use. So in the end, we got this one. And then we also have what's called runtime polymorphism. This is quite big. Also known as dynamic method dispatch, it happens due to method overriding, where a child object gives a different implementation, what we have just done. It overrides the parents one, the method's implementation is different with the same name. Yes, the example we made basically, yes. And the last pillar of object-oriented programming is inheritance. The most heard, but the last I say. Basically, as the name suggests, the children inherit everything, not just method definition, but also its implementation. The only difference between inheritance and abstraction is that abstraction methods can either be abstract or concrete, whilst inheritance from concrete object must have an implementation. Okay, so let's just paste this code so I can explain it better with color. Yes, this is not abstract. This is not abstract class, hence every object, every method needs their implementation. And then dog can override it, cow can override it, cat can override it. That's basically it. The animal is living. Polymorphism is the same between inheritance and abstraction. Same method name, different implementation, but okay, we'll talk about it later. So that's basically it for day 1. And before we'll move to day 2, I must say thanks to these 3 amazing sources that I take to compile the day 1. These 3 are totally helpful, especially the Geeks for Geeks. This is the goal. Okay, before we go further, before we go further. So without further ado, let's go into day 2. So the first section we'll cover is the Java philosophy. Never forget, Java was created for enterprise system out of the frustration with C++ freedom. C++, as C do, give you too much freedom, but also give you too much features. So Java prevents ambiguousness, resulting in verbosity and problems caused by too much freedom. So everything in OOP revolves around inheritance. I want to correct myself. Everything revolves around inheritance. So abstraction is just abstract inheritance. And then, yeah, that's basically it. Okay, abstraction is not that one. Okay, I'll explain it later, but for now, let's just think inheritance as the verb or how we do it. This is the example we've talked about, so no need to talk about it again. And inheritance, you have 3 types of inheritance: abstract inheritance, interface inheritance, and concrete inheritance. The first one is abstract inheritance. Don't get fooled by the name. The abstraction we discussed is a design strategy. You don't need to know everything for it to work. My mistake if I said anything that confuses you, but basically abstraction is hiding the object, you don't need to know everything for it to work. Abstract inheritance, on the other hand, means you don't need to provide how the method should function. This is what we talk about. I'm sorry, abstraction is actually about the hiding most of the things, so you don't need to open it unless you need it. So this is basically abstract inheritance. A shape has a draw, has an area, and has a perimeter. So rectangle extends the abstract class, and then during the constructor, put the side inside the variable of the class, and then when draw, it returns the name of the class, return the name of the shape, and then it returns the area and the perimeter. The same for circle. And then we create an array of we create an array, and then we put the shapes put the shapes of rectangle and circle into the array. So then we iterate through the array and calls every single method. Delicious. Okay, let me fix that. I still haven't learned about the norm in Java development, so forgive me if I ever do something wrong. So this is basically it. I should have put the code right here. Yes, this is it. And then next we have interface inheritance. So interface inheritance basically declares method that this class will have and have them inherited. That's it. With the catch that a class can have many interfaces. I just implement one right here because, to be honest, I was lazy. Okay, so we have mammal method, a method that a mammal has, eat, sleep, and speak. But this is not allowed. Interface must be specifically abstract. And we have human implementing the mammal method. We eat, sleep, have name, and have age. And then the same with monkey. They have name and age. They have eat and sleep as well. So we create this one, and polymorphism, instantiate a new object with the mammals method, instantiate a new object with the mammals method, and then you can do polymorphism with interface, but it's limited to the method inside the interface. Yes. The human ate rice and sleep. The monkey ate banana, and there's a new table unlocked. If for concrete and abstract inheritance, you have a virtual table for looking which method to implement. An interface inheritance, we have an interface table or interface method table. So when you call human.eat, Java virtual machine goes to the object metadata and look at the ITable. Then it goes to the it definition and jumps to the implementation in human metadata. Yes. So that's basically, correct me if I'm wrong, alright? But JVM goes to the object metadata, sees it's actually quite circular. I don't really know about the so class word goes to the sorry, it goes to the class word, go to the class metadata and sees that it's implementing eat, and then it goes to the ITable and then go to the where the method is implemented. Yes, that's basically it. Correct me if I'm wrong again, alright? This is public learning, not teaching factory. So the next one is concrete inheritance. As its name suggests, this is concrete. You inherit everything, and if you don't override, the children will be 100% the same as their parents. A parent has job, hobby, and then they have work and hobby. The child is the same if you don't override anything. Create a new parent, yes. A new child can also be with the family type, can be also with the parent type, but it cannot be the opposite. Okay, because a subclass, a children, have everything that their parents have, but a parent won't have everything that their children have. So it's not both ways. So when to use which? Use an interface when you want to define a behavior regardless of who is doing it. It's a can-do relationship. It doesn't matter who, just what it can do. Use an abstract class if you have a base type that shares the same code, but the type itself shouldn't exist on its own. It's a relationship. So a dog and a cat are animals but don't speak the same way. Use a concrete class when object is fully functional on its own. Basically, when you inherit it, you'll only trigger it. And next, the big one, VTable and ITable. What are they? First table is a table that is an internal part of the JVM. So remember the class word? That's right. For every class, a JVM creates the metadata in the method area, which is just basically the data and text segment equivalent. Remember the class word? That's right. For every class, a Java virtual machine creates the metadata in the method area. Yes, and stores a hidden pointer in the class word. So when the JVM wants to object of the same concrete or abstract parents, they see the shape class and then run the method. The JVM looks at the class word, which is just a pointer to the class metadata, and goes to the class definition and metadata before finally, this is a bit of a mistake on my own, look at the virtual table or ITable to finally get where the implementation of the method actually lives. So ITable operates on the same basis, but with a higher performance stacks. When you do m.eat, the JVM goes to the class word of the class. It looks at the ITable and searches for the mammal method identifier before finally jumping to code. The real performance comes from that in VTable, the implementation is always the same. What I mean by that is the index. A VTable has the index sorted out. So the speak first and then sleep and then speak. But in interface, you can stack many interfaces. So the index will be very different. That's why there's a performance cost. Correct me if I'm wrong, but that's what I learned. While a mammal might implement other interfaces like Ting, we need to search first where the implementation is. However, again, with just-in-time compilation, hotspot optimization, called inline caching, if you do it multiple times, it becomes as fast as VTable. So that's basically it for the inheritance. And then we have the static Java versus static C. Java is really verbose, yeah? It's already 5,000 words. Yeah. So now in C, a static or global variable means it lives in the data segment, where it'll live on for the rest of the program. Java combines the data and text segment into the method area. So the principle is the same, a variable that will live on for the rest of the program. Remember, a stack variable, which is the primitives, a reference variable, or an instance variables, which is reference the heap object, lives on the, yes. And now we have static variable. It lives in the method area, and all instances of the object share this one variable. And a static method is quite the same. It belongs to the class, the blueprint, not an instance of a class. So okay, let me put this one into the VS Code first so I can explain it better. So this is class testing, right? Before I forget. So we instantiate a new testing class. This is class testing. We have a static variable called variable. And then we have a string variable called testing ground. So we put the testing ground into the variable. Now its instances of testing have a pointer or reference to the variable variable. And then we have the change global variable. This is owned by testing, not instances of it. A static variable can only be changed by the static method. We create a new object, it prints the static variable, and then this one doesn't change static variable, it only changes where the testing ground points to. And then we print the other one. We change the global variable. This change the global variable of variable. This doesn't change the new static variable. Because string is immutable, it only creates a new string object and points there. Since the old object is still there, testing2 still points to the old object. It is a copy of the reference, not a live link. So if we want to see the true, if we want to check if the value has changed, let's create a new class called testing3. testing. What should I put? Oh, blah blah blah. No need. And then we system out the print. It should change. Not testing 1, but testing 3. Let's print as 1. As you can see, the first two prints hello world. The second one only prints hello because of the testing 1 change points to a new. We still prints hello world. We change the global variable to hello bro, but the testing 2 still points to the old string hello world. And when we create a new class that points to the global variable, static variable, may I correct, it prints the new value. That's it. And then we have the static variable, we have the static method. What about a static class? You cannot declare a static class on top of a file, so you cannot just create static class, no. But you can inside another class. This is called a static nested class. So let's put this one. Yes. We have a universe, and then we have how many stars. This is a static nested class. We have a star. It can access the static variable on the parent class. But it cannot access instance variable of universe because there is no this pointer to a universe object. No universe object needed. We can just create that new one. That's just it. Why do we even need this? The main reason is encapsulation. If they're both in a different class or file, they need a getter, etc. But allowing a static nested class to edit the outer static variable, the inner class can edit a private variable directly. And last one, the final one, the final keyword. Final, not exactly as the left. Genuinely. So let's end today's note with final keywords. Final equals final. No changing, no extending, no inheritance. A final variable cannot be changed like const. A final method cannot be overridden by children. And a final class cannot be extended or inherited. An example is string. You cannot extend a string. Yes, class human, we have a final string. This name is not allowed. A variable cannot be changed. How? Yes, this is correct. But however, you can do this. You can do. Sorry. Okay. This is called blank final, right? Yes. Okay. If we do like. We have immediately assign a value to the final string name. We cannot change it forever. But if we have what's called a blank final, it can be assigned one last time before it's locked forever. Not allowed. A final variable cannot be changed. However, that's what's called a blank final. You can initiate a final string and reassign it in the constructor. And then we have final private void speak. Then we have the class robot. It extends everything, not anything. And then override is not allowed. A final method cannot be overridden by a child's method. Now, main cannot be extended for security reason. Sorry, not that one, but this one. Yes. With final, you cannot extend that one. That's basically it for day 2. And finally, we move to the last day 3. I'm actually kind of, how should I say, mad at this one. I lost today's entire note, so now I'm here rewriting this from scratch. Yesterday I was pretty busy, so I didn't have time to write the note like usual. So I wrote it this morning from around 7 a.m. to 9 a.m. when it's 90% finished, 95% dare I say. But then I closed Chrome. I wrote this first on GitHub issues, right? And then I lost everything. So I rewrote everything, which is not the prettiest, but I think it's more accurate. So we got back to the first question. What is an object? We already know object is an instance of a class, but what's behind it exactly? An object is just a struct with the header. Yes, that's basically it. A class is an object with a header. Not an object with a header, sorry. an object is a struct with header. Yes, that's basically it. Class is a blueprint for an object. It contains the information for object and is stored in the method area. Object is an instance of a class and is actually just a struct with a header. In the class word located in the header, as we talk about, a pointer to the class metadata is stored. Inside the class metadata has a VTable and an ITable, if you do, which has the index of where the function or method actually lives. And where do function live? The method area. Split into meta space for functions that are still in the bytecode and code cache for quote-unquote hot function that has been run multiple times and has been compiled into native machine code. And just remember, in C and every language practically, everything is contagious. So an object being a struct and having a pointer to the method is nice. Alright. For you're asking why I have package OP here, yeah, I've started using the VS Code, so yeah, package helps a lot here. Now I still have the code. Yes, everything went missing. The node was lost, but I still have the code since I coded it in my VS Code. Thanks finally. And then this Java code still has the full object-oriented programming pattern. Not full, but yeah, you get what I mean. Oh, what? Kenapa ini? Huh? I don't understand. Now, the folder name is object-oriented programming. What do you want? The constructor. Oh my god. Alright. Sorry. So let's get this started pretty quickly, alright? So this code is totally wrong. Let me fix that one first. Alright. This is the C word. No! And then let me rewrote the last one. This was also wrong, to be honest. Day 3, right? Alright. And then we have the compilation of my Java obituary. Yes, that's basically it. And then we go to the very bottom. Should be correct right now. Yes, should be correct. So let's update this one. I'm sorry for the delay. Let's get back to this. So where were we? Yes, object is a struct and header. So this class is basically a struct with a method something called like this. Let's run the Java first. It'll get clearer once we get into the C program. I didn't know what I was singing, but yeah, that's basically it. And then now you already know about the Java, right? Oh, this is the explanation. Okay, so let me explain it first, alright? my dog wiggle tail allowed because in dog's table there's a pointer to the wiggle tail method. Not allowed because in the animal class there's no wiggle tail. This let out the bark even though it's an animal, the JVM goes to the class VTable, not the animal one. Bark as usual. So this is a struct with header, mark word and class word, and then we have the struct has these variables. Methods don't live in struct, they live in the method area. So when you call animal.speak, the JVM goes to the class word. Inside its class word leaves the pointer to the method stored in the methods area. It accesses those address and start executing the at that index. So when you inherit an object, it's basically a copy paste. We create a new variable inside the child class with the exception of header. So an identical object still has its own identity and add this to this. Override will basically tells the JVM to change the speak method in the method area and go into the new address or index. New method, this is new method, just adds new method to the method area and add new address at the end of VTable. That's why VTable is faster than ITable because the index is almost always the same. Yes, this is basically what we have talked about, so let's skip that one. And then we got finally into C. This is what's basically happening behind the scene. I tried recreating it, not perfect, but you can see it is working. We are on the main and we run. Okay, max at 3 foods, max sparks at 78 volume. So first of all, we inputted all the libraries we'll need, and then this is here because animal needs animal metadata and vice versa. The this pointer is passed to the first argument automatically. Oh, okay, was a bit of a mistake, but let's put this one. Oh, no need to. Then we create the metadata with the methods that the animal used, and then we instantiate that automatically. Then we have the animal struct which has the pointer to the class to the animal metadata, and then have all the variables you'll need. This is basically the constructor of new animal. This is the constructor. Remember that every object is just an instance variable that points to a heap object, and then a stack variable pointing to a heap object. We put the name to animal name, and then we put the age, we put the metadata, and then we return the address. This is the methods implementation, and then we bootstrap the animal.class, which just basically put the implementation there. We create the animal metadata, and then we instantiate a new object, and then we call max.eat. It performs what I talk about, alright? I'm already speaking like this. Yes, that's basically it. Just keep in mind, this is not full object-oriented programming. I'm not that good. This is just a struct header mimicking object. And then we have the inheritance, basically struct inside struct. So inheritance is a struct inside struct. I'm gonna implement concrete inheritance because inheritance and abstract are very familiar once you understand behind the scenes of concrete inheritance. Yep, the animal part is basically the same until you get to this line right here. Basically the same. We create the dog struct, but for the dog metadata, we have the animal metadata first inside directly, and then we add the new methods. Leave it empty at global scope, and then we have a new dog class which has the parent object, parent struct, and variable unique to dog. This is the constructor that returns the dog address. We malloc, we initialize the memory, and then point to the dog specialist VTable. Yes, but we need to typecast it into animal metadata because the dog parent is actually an animal. Yes. We initialize the name, age, and string as usual. This is the method, and this is the overriding. Methods are just global function. They pass the animal inside. Oh, sorry. Then we bootstrap everything, and now this works. We have dog speak. We override the animal metadata of speak with dog speak, and then wiggle tail, and then is safe. This is bootstrapping the class word during runtime. Before you process run, we instantiate a new object like usual, animal named Max, the same as usual. Now, this is polymorphism in C. We can, copper will eat, but it will output, oh, I didn't override the eat, so it's the same. And then we create a new doc variable, and we need to create a new doc table because, oh wait, let me try that one. Okay, let me try that one first, alright, without the doc VTable. We have Charlie dot parent dot class metadata dot speak animal test. We pass the Charlie is already an address, and then we have volume at 90. Let's try that out. I hope this doesn't seg folded. Yep, seg folded if I'm not mistaken. Oh yes, because I passed a dog. Equal an animal. We need to bypass that one first. Okay, before the looping, bark. Yes, Charlie barks. Because Charlie has a special implementation, we override the methods right here with dog speak. But for other methods, you need the dog VTable action directly because animal doesn't have wiggle tail or is safe. Wait, let me try again. Charlie. Yes, you can do that. So then we have an animal array with Charlie being typecasted as animal. You need to typecast Charlie, and then we loop through that one and call speak. And then yeah, we have polymorphism in C. This is object-oriented programming like completely unsafe and the absolute foundational of core OOP languages. It is unsafe because no free, yes, I forgot to put free even though I manually allocated everything. We have no garbage collector as well, and then blind casting. I forget what RTTI is. Let's search that one. What is RTTI? Runtime type information. Yes. So basically, RTTI makes sure you can typecast safely and sanely. Yes, that's basically it. So because if you typecast an animal to dog, an animal doesn't have wiggle tail, and if you call wiggle tail on animal, undefined behavior. If you typecast Max to dog, which is an animal to dog, Max has no implementation of wiggle tail, and boom, undefined behavior. We have undefined behavior. It is OOP light because no encapsulation, anyone can access the data, and no exceptions for failures. And the last one, this is hell. Also this. Losing my notes is enough, but now I need to learn this keyword. As you can see in my C example, it's passing the address of the object to the function. This keyword basically does that. This stores the reference to the object, so when you call this.method, it goes to the class word, class metadata, VTable, and the function with the reference as parameters. That's basically it for week 2 of Java, which is week 8. And I thank you all for watching. And I'm sorry, feel free to correct me if you found any mistake, because this is just public learning. As I said, I don't intend to teach anyone, and if you found this helpful, yeah, thank you, I guess. Why I'm thankful. But as I said, if you have any input for me, feel free to say it in the comment section. And I must thank you for watching today's video, which is just me yapping for how many hours? Okay, 50 minutes. Okay, so now I, Bernardus, signing off. See you next week. Thank you.